Alright, so this is 13.4 and 13.5 combined. Is transferring water the answer, and is converting seawater to freshwater the answer? Okay, so water is transferred via tunnels, aqueducts, or underground pipes. South Florida, as we stated in the last lecture, is so water thirsty because their Biscayne aquifer has saltwater intrusion. They have a very large growing population. They're asking North Florida to pump them 90 billion gallons of water every single year from the northern part of the Floridan aquifer. And North Florida says, no, we're not going to do it because we have a growing population here, and we're not going to take this water and send it to you guys. You guys got to figure out your own situation. So let's see, California's water project moves water from Northern California to Southern California, mostly for agricultural purposes. Remember, 50% of the fruits and vegetables grown are grown in Central Valley, California. So they need that water there. It's a huge part of their economy, as well as the not just for eating, but wine. The wine area of California, very dependent upon water, is also a very huge industry, not just in the United States, but California is known for their wines worldwide. So it does not allow the San Francisco Bay to flush. So instead of the water flowing through San Francisco Bay, which helps push and turn out that water, right? They want to, what would you say? I guess move it around the bay and then bring it to the other part of California, and that would cause that water in the bay to stagnate, which would cause a huge dead zone, right? And we know that in those dead zones, nothing survives. Anything that would be trapped there would become rotten material, which would then vacate gas to the atmosphere, greenhouse gases, carbon dioxide, and methane. Horrible. And farmers have no incentive to improve efficiency. Government subsidies, we talked about that last slide too. If we would front load the subsidies to allow them to improve equipment, it would be better than paying them the subsidies on the product that they create. Distillation, that's what that first one says, is evaporation via heat. It is the same type of distillation that we talk about when you're thinking about spirits, meaning whiskey, right? You are heating something, causing it to become a vapor, and then collecting the vapor. That's distillation. It's very costly. Between these two, the most expensive is distillation. You have to burn something, so it's going to have to be coal, oil, natural gas, some type of electricity needs to be produced to create heat, to create steam, and the vaporization of this material, in this case being water, and then again you collect it and you leave the salt behind. The problem though is that you take this salt, maybe this in the next slide, I'll wait for that. Reverse osmosis, if you look at any bottle of water that you buy at the store, a lot of them will say reverse osmosis on there, right? And it's reverse osmosis because you're forcing water against its natural gradient, right? In a way it does not want to naturally move. And you, at very high pressures, you force it through this membrane, which then pulls the salt out and extracts the salt as you push it through this membrane. Alright, drawbacks of desalinization. Very high cost as far as money and energy, again, because you have to burn and fuel. Right, so then to produce large quantities of this water, enough for people to drink, shower, and bathe in, very expensive. So, of course, we've got to keep the pipes that we're pumping the seawater through clean, so we've got to use chemicals to sterilize it, which then gets into the water. And hey, surprise, surprise, these chemicals, just like most others we put in our water and into our bodies, are endocrine disruptors, which mess with our hormones. Our body accepts them as estrogen, and again, which just adds and perpetuates the, I hate to say, feminization of our species. But like we said in class before, sperm count used to be 600 million sperm, now it's down to 300 million. It's been reduced by half in the last 100 years. We have the super salty brine that's left over. So once we vaporize the water and collect it, we've got all the salt that's left behind. What do we do with it? So much salt, it's not more than we can sell at a store. Plus we got to get rid of it soon in this facility so we can get more water in there. So what they do is they take it and they exhaust it into the ocean. But now, the ocean, which has a salinity level of about 3.5%, now you take it, you dump all the salt, that was loud, all the salt into an area, and the salinity is just jacked up in that area for a while. So anything that swims into it dies because, yeah, animals live in salt water, sure, and there's fish and there's mammals, but they're used to a salinity level of 3.5%, not what's in that super salty brine. And reduces ions that are essential for plant growth. Yes. And that is the end of those two. Hope you enjoyed it. That was a nice short one.